Hi, everyone. Thank you for joining us. My name is Michelle Ladera. This is the webinar for Changing Developmental Math from a Gatekeeper to a Bridge, the Promise of New Math Pathways. Before we get started, I'd like to mention a few housekeeping items. Please submit questions for the presenters at any time by typing in the Q&A window. We will be collecting the questions for the dedicated Q&A time at the end of the webinar, but may also be able to address questions at appropriate times during the webinar. We will be providing links to resources throughout the webinar through the chat window. You should feel free to talk to each other and share resources through the chat window. The webinar is being recorded and will be archived on the REL Northwest website along with the slides. This is a webinar of REL Northwest. REL Northwest is one of 10 regional educational laboratories funded by the Institute of Education Sciences at the U.S. Department of Education. REL Northwest works side by side with stakeholders to conduct rigorous research, analyze data, provide technical assistance, and share evidence that can improve education decision-making. We serve 5 states: Alaska, Washington, Montana, Idaho, and Oregon. And we are based at Education Northwest in Portland, Oregon. This webinar has 3 presenters. Myself, I am a senior researcher at Education Northwest. Dr. Jenna Cullinane is the Higher Education and Strategy Lead at the Charles A. Dana Center at University of Texas at Austin. And Doug Nelson is a longtime math faculty member at Central Oregon Community College in Bend, Oregon. The agenda for today is I will briefly review the webinar objectives and provide some brief data and research on developmental math to set the context. Next, Jenna Cullinane will describe the new Math Pathways project. Doug Nelson will then describe grassroots efforts to implement math pathways at the Oregon Community Colleges. After their presentations, they will address your questions. We welcome questions at any time. Please use the Q&A window to submit questions, and we will address them at the end of the presentation or if we have an opportunity during the presentation. There are 2 objectives of this webinar. First, participants will gain an understanding of the gaps in math knowledge and self-confidence of incoming college students and how the traditional delivery of developmental math does not meet the needs of all students. Second, participants will learn about Math Pathways, a new strategy to improve college math learning and persistence. Okay. So to begin, I'm going to begin with some brief data on developmental math to provide some context. As you may know, many students in this country begin college in developmental math. I'm going to present data on a nationally representative sample of students who entered college in 2003. 60% of students who entered a public 2-year college took a developmental math course. 33% of these students who entered a public 4-year college took a developmental math course, and 22% of students who entered a private, not-for-profit 4-year college took developmental math. As you can see, many more students took developmental math than developmental English because underpreparedness in math tends to be much more pervasive than underpreparedness in English. High rates of participation in developmental math are a concern for several reasons. While developmental education courses may improve the academic skills of those who complete them, attrition from developmental math is high and few students finish their developmental education course requirements. Developmental education students also tend to have lower graduation rates than their counterparts who started college in college-level math. Finally, developmental math is costly for students. Students spend an estimated $6.7 billion per year on such courses at community college. Yet for large numbers of these students, the investment of time and money on developmental math coursework yields little progress towards a degree. Let's look at some specific data on on developmental math attrition and completion from Oregon. This data is from a published Brown Northwest study that you can access on our website. Here we are looking at the traditional developmental math sequence at the Oregon community colleges. While it varies from colleges to some degree, the typical sequence has 5 courses: arithmetic, pre-algebra, intro-algebra 1, intro-algebra 2, and intermediate algebra. The course numbers are in parentheses in case we have some Oregon listeners who are familiar with these courses. Keep in mind that Oregon is on the quarter system, so each of these courses takes 1 quarter. Among recent high school graduates who enrolled in Oregon community colleges between 2005 and 2012, right after graduating from high school, 3% started in arithmetic, 14% started in pre-algebra, 22% started in intro-algebra 1, 14% started in intro-algebra 2, 11% started in intermediate algebra, and 17% started in college math. 17% of students never took math. And so overall, 2/3 of recent high school graduates took a developmental math course. This is similar to national statistics we see on developmental math enrollment at other community colleges. Let's focus on, oops, sorry about that. We're going to focus on, oh, that did not work. In students who started intro algebra 1. So we're focusing on the attrition of students who started in the highest enrollment developmental math course in Oregon. So we're going to zero in on students who entered community college between 2005 and 2007 because we want to look at their progression through the math sequence and if they ever earned a college credential. And so we're looking at data across 5 to 7 years. We're tracking them for a long time. And this data is linked to National Student Clearinghouse data, so we can look at if students ever earned a certificate or degree from any college in the United States. So we begin with 6,302 high school graduates who entered Oregon Community College right after high school, and their first math class was Introductory Algebra, or Math 60. So 30% of these students did not pass Math 60 or passed but did not enroll in the next course. As you can see, most of these 30% of students actually dropped out of college altogether, representing attrition from college, not just developmental math. 2% of them show up in the NSC data as earning a certificate or degree at another college. So we have 4,393 students that progressed into Math 65. At this point, 20% of the sample did not pass Math 65 or passed but did not enroll in the next course. 16% of these students left college altogether, and 4% left the sequence and completed somewhere else. So we see them show up at another college and completing. We have 3,099 students who progressed into Math 95, and we have 17% of these students who left the sequence at this point because they didn't pass Math 95, or they passed, but they chose not to enroll in the next course. And you can see, again, most of these students left college altogether, 14%, and 3% left the sequence but completed somewhere else. So we're left with 1,991 students who progressed into college math. 5% of students did not pass college math, and most of them left college altogether. 11% passed and left college, and we have finally 15% of students, or around 14%, who passed college math. They completed this math sequence, and they completed college. And so that's, in total, when we're started with 6,302 students, we have around 800 students who actually completed the sequence and completed college. So the main takeaway from when you look at progression of students through a traditional developmental math sequence is that long sequences provide multiple opportunities for students to leave the sequence and college altogether. And so one of the primary directions for developmental math reform is to shorten sequences. But traditional developmental math sequences are not just long. The traditional content may not be aligned with the skills and knowledge most students need to be successful in their degree programs and careers. In a 2013 report from the National Center on Education and Economy, the authors did an extensive review of the mathematics curriculum required of popular community college programs, and they found that many community college programs require little or no use of mathematics, and most programs that do require mathematics require math content that's taught in middle school. These skills are around mathematical modeling, statistics, and probability. However, one observation they made is that students are often rushed through these important mathematical modeling, statistics, and probability concepts in middle school in order to get through the traditional math sequence that leads to Algebra 2 in high school. And as a result, traditional high school math programs do not review or help students master these important concepts from the middle school curriculum. They conclude that for most students not going into math-intensive fields, mastery of these middle school concepts are far more important for both college and career success than mastery of Algebra 2. So I'm going to pass the presentation over to our first speaker, Jenna Cullinane, who's going to talk about reforms that are revising the developmental math curriculum and ensuring that the content is aligned with many students' degree programs and career goals.
Thanks, Michelle. Hi, everyone. Jenna Cullinane. I'm going to be talking, as Michelle said, about our work with the new Mathways Project, and that work has begun in Texas and is increasingly growing in other states. And in general, this is kind of a model for reform around math pathways, as well as encompassing specific work in specific states. So when we talk about the new Mathways Project, we speak about it as kind of an umbrella term to refer to this new approach to both developmental and gateway mathematics. Our goal is to significantly improve student success, both for students who come in underprepared and those who come in directly into college-level courses, because we know that kind of developmental education is not an end to itself. What we really want is for students to be successful in their college-level courses and start to build momentum towards their ultimate goals of degree or certificate completion. So our work is based on 4 principles, and 2 of the principles that you've heard Michelle highlight are our first 2 principles, and that's really where I'll focus most of the discussion today. So the first is around the relevance of the skills, and that we recommend multiple math pathways that are aligned to specific fields of study. So we argue at both the gateway level, that first college level course, and at the developmental level, that the math skills that students are learning really be tied to the needs of their program and the needs of their future career. And there's often this kind of serious mismatch, as you heard from the study that Michelle just talked about, between the kind of traditional algebra content and the needs of students in their programs and in their careers. The second big principle that guides our work is that of acceleration, and really wanting to move students much more quickly to and through that first college level or gateway math course, and we recommend in a year or less. So for students who are coming in college level, we want to see them being successful immediately in that college level course, and for those who come in underprepared, that they're able to really gain the skills that they need in preparation for their college level course quickly, efficiently, and really focus again on those relevant skills that are going to help them be successful. Our third and fourth principles have to do with incorporation of student learning strategies and helping students become good college students, college learners, in addition to being competent in the mathematics. And then we also talk about curriculum design and pedagogy based on proven practice. So this is a little bit more information about when we talk about multiple math pathways, what do they look like and what does relevance really mean? And this is a partial view. We really focus on 3 pathways: a statistics pathway, a quantitative reasoning pathway, and a STEM prep pathway. And certainly these are not exhaustive. There might be other pathways that states or institutions use for business or for teaching, for example, or maybe for tech programs. But these are the 3 that we spent a lot of time working on. The statistics pathway in particular is designed to help support students in the social sciences, and also in health and allied health programs, based on an assessment of kind of the needs for those programs. Our quantitative reasoning pathway, sometimes called contemporary math or math for liberal arts, is really designed to support students in the liberal and fine arts programs. those for whom kind of a single math course is typically their sole experience and the sole preparation that they're getting in mathematics during a program or certificate or degree. And then our STEM prep pathway refers to the accelerated pathway for students who really do need to go on to college algebra, pre-calculus, calculus. For those who are going to be in mathematics-intensive fields, we know that students are not very successful in these long sequences of developmental courses, and in addition, they have quite a ways to go in terms of being ready for calculus. And so this third pathway refers to the accelerated structure both at the developmental and at the college level to really prepare students who are moving into STEM programs. In order to implement math pathways, we've learned that this work can't just be done within an individual classroom or an individual institution. This work really requires whole system change. And so we work at multiple levels of the system to help enable implementation at the institutional level. So our work at the national level is really in concert with the math professional societies, who I'll talk a little bit more about in a minute, to help legitimize this movement towards multiple math pathways and away from thinking about college algebra as the default math course for most students and really challenging long sequences of algebra-intensive developmental work. At the state level, we help support building kind of state-level urgency and vision around this shift towards multiple math pathways at the developmental and gateway levels, and take on policy issues related to transfer, applicability, making sure that different kinds of math courses are really going to count for students' degree programs, even if they transfer across institutions. And things like placement, for instance, is another kind of state-level issue that might be relevant. At the institutional level, we help support institutional change broadly. When you're making changes to math courses that might be policy changes related to your core curriculum or general education, might be changes to degree programs, might require changes to your tutoring offerings, advising supports. This really is full institutional change that's required in order to embed a multiple math pathways approach into how you serve both college level and developmental students. And finally, we do work to support faculty in classrooms. We do a variety of professional development. We offer curricular tools that are optional resources for folks who want to use them, and support educators in the process of implementation. So going back a bit to the national level of work, I wanted to highlight a couple of quotes from the Math Professional Society. So sometimes people think about, this is an initiative of the Dana Center, or this is an initiative of the Carnegie Foundation, the Statewide Quantway work, for example. But really, this movement towards multiple math pathways is much broader, and there's quite a bit of buy-in and support among the math professional societies nationally. Here, this is a recommendation or a quote coming from the Mathematics Association of America, actually back in 2004. And I like to share this quote because I think it helps explain that this is work that's been going on for more than a decade, but it's really starting to take off in terms of implementation and changes in state policy, which you'll hear a little bit more about. But what they point out is this issue around relevance, that there really is often a serious mismatch between the original rationale for college algebra and the actual needs of students who are taking those courses. And they ask that people take a look at, are students using college algebra as a terminal course? Really, college algebra was designed to be a preparation for moving into pre-calculus or calculus and on into the STEM fields. But a great many students are often defaulted into a college algebra course, even if their program doesn't require a lot of algebra, and often are taking these very long sequences of algebra-intensive developmental coursework that doesn't really match the needs of the students. And beyond this, recently, in the last year, a group that involves almost all of the major math professional societies in the country came together to issue what they called a Common Vision Report. And what they did is they reviewed all the recommendations from the various professional societies, and what they found is that there's all of the math societies are now recommending math pathways, and they have really identified math courses as the most significant barrier to degree completion, both for STEM and non-STEM programs. And so they talk about kind of the low levels of passing in college algebra and the real mismatch between college algebra, that only 10% of students who are taking college algebra are ever going on to calculus. So this intended design of college algebra as a preparation for calculus isn't really even working in practice. And so we see, as I said, quite a bit of support for this work, not only in the math societies, but in the national higher education organizations as well. APLU, ASCU, and NASH each have major initiatives now where they're engaging primarily universities and university systems in this change. So we see a real expansion from some of the earliest work really focused on math pathways as an approach to developmental education, but now growth and outreach into really thinking about that college gateway course and understanding that both pieces need to be coming together in order to implement math pathways. Further building on this relevance issue, this is a study, this is actually from a brief from Pam Berman based on a couple of other studies from NSF and others, that take a look at the proportion of students in different programs. So when you're thinking about the scale of math pathways in terms of how many students might be supported by a pre-statistics and into a statistics course at the college level, or a pre-quantitative reasoning type course into a quantitative reasoning college level course, what we see is the vast majority of students are in social science, health, liberal arts, fine arts types programs, and that the minority of students, just 20% of students in community colleges and 28% of students in four-year institutions are in STEM programs that require calculus. Now moving into a bit of the Dana Center's work, specifically around how we support and advocate and help implement math pathways, you'll see on this map a variety of states where we're working. In excess of 12 states now. We have been working, you'll see the states in orange, and you'll see both Washington and Montana from this group are included there, who are working in what we call our math task forces. And I'll talk a little bit more about those in a minute, but essentially they are ways to kind of organize at a state level and address the policy and capacity issues and to support implementation of math pathways. And then a variety of other states, as I said, this work really started in Texas, working very deeply with all 50 community colleges in the state, and then now expanding out to several other states that, for instance, Maryland is a first in the world state. Massachusetts is taking this on as kind of a Department of Education initiative. So a variety of states are really moving in this direction, and what you'll hear about is there are many other states, including Oregon, that are taking this work on their own, and so this idea is really spreading across the country very quickly. In our state-based work for these math task forces, which is probably most relevant for our Washington and Montana folks have been engaged in this work for 2 years, and the Washington folks just started this year. But what we help do is bring representative groups of 2-year and 4-year faculty together to help set a vision around an approach to increasing student success in developmental and gateway mathematics. And that involves helping to build urgency and motivation for this kind of work throughout the state. What we find is if just a couple of institutions or maybe just one sector, sometimes you run into challenges in terms of transferability, admissions into universities, that kind of thing, if it's really not done at a state level. So that's why we start there with math faculty at the fore. We talk about this work as faculty-led and administratively supported, and it's done in conjunction typically with the Department of Education or coordinating board or even a success center maybe who has statewide purview. And from there, task forces really take on the policy and practice conditions that are needed to help with a statewide rollout of multiple math pathways. So this might be changes to placement policy, adding a particular new college level course or developmental course to your transfer inventory or transfer library. It might take on how rollout is going to happen. Are a third of the colleges going to start implementing this year, and another third will start next year, and another third in the third year? You know, these are the kinds of things that states are planning for broad system change. And then in the third phase, institutions are actually enacting the vision around multiple math pathways. They're beginning to plan for, schedule courses, and teach courses. And so we do this work through a variety of kind of consulting tools and services, and we'd be happy to talk a little bit about the experiences in Washington and Montana if folks are interested in that. So as I've alluded to in a couple of different ways, This work is really much broader than institutional work and does require coordinated policy efforts. And I've already mentioned kind of transfer and applicability issues. Applicability really being making sure that multiple math pathways are really going to work for the program of study for a student. If College A wants college algebra for their nursing program and College B wants statistics for their nursing program, students in transfer will have a problem. They'll just end up with elective credits and not really satisfying the degree requirements. So this is the kind of thing that I'm referring to when I say applicability. And what you'll see in the image there with the arrows and the blocks is an example from Texas that has kind of the full gamut of math pathways and really lays out a framework for applicability. So which kinds of majors, which kinds of programs match which math pathway, and you'll see this kind of organized by meta major. And this is a framework that's beginning to guide our work across colleges and universities in Texas. We learned that we needed a statewide approach to this kind of alignment work. Other issues that might come up are definitions of college readiness or required prerequisites for certain college-level courses. If you're redesigning at the developmental level, you might have different designations of college readiness for someone who's going into an algebra-intensive pathway or a non-algebraically intensive pathway. And there are also sometimes rules or policies around acceleration structures or placement that need to be addressed when implementing math pathways. I also wanted to mention the Dana Center's curricular work. This, as I said, is an optional piece of implementation. There's always some misconception around this, so I do want to emphasize that when we talk about multiple math pathways, many colleges and universities implement their own homegrown version of these courses. They develop their own curricular resources, or they use existing textbooks and resources that are out there. For some institutions, the idea of redesigning their developmental sequence, especially for students who are going into a statistics or quantitative reasoning pathway, they'd rather evaluate existing resources, and so the Dana Center helps provide those for those who are interested. So what you'll see in this graphic is an example of our curricular resources, or a diagram of our curricular resources. And so what you'll see on the left-hand side is a one-semester developmental experience where students are taking what we call our Foundations of Mathematical Reasoning course. And as I said, that's a developmental course really based in quantitative reasoning, also includes some algebraic reasoning and some statistics and probability, number sense, that kind of thing, but really designed to help students much more quickly in one semester go directly into a college-level quantitative reasoning course or a college-level statistics course. You'll see from that Foundations course, for those who are going into our STEM prep pathway at the bottom there, they would then go into a two-course sequence, what we call our Reasoning with Functions 1 and Reasoning with Functions 2 courses. And that's designed to get students ready to go into calculus. But again, you'll see it's for each of the three pathways, students are spending just one semester in a developmental course if you lay it out this way. You'll notice the STEM prep pathway, people always say, how can you really be ready for a STEM, college-level STEM course in a year or in a semester? And what you'll see there is that you'll see it says 5 contact hours, and that is because that's done in a co-requisite fashion where some additional algebraic reasoning skills are developed just in time in that first college-level course. I do want to emphasize that this is laid out in terms of separate semesters, that a semester of developmental and then a semester of quantitative reasoning, for example. But we strongly recommend the co-requisite structure as well, and know that just know that these can be done in a one-semester approach as well, where the developmental work is done more in a just-in-time manner. But I wanted to talk a bit about and highlight the courses so that we could get to one of the key issues that Michelle wanted to highlight in this webinar, which is about student confidence and student knowledge about mathematics in terms of traditional delivery and in this accelerated and relevant approach. So this information is actually coming from our external evaluation partner, MDRC. They have helped do some classroom observations, and they're in the midst of a rigorous randomized control trial of our work in Texas. But this is some of their preliminary work, not yet published, but that has been gleaned from their initial observations. And what you'll see in this table, down the center, you'll see some of the curricular design principles that undergird our curriculum work in particular. And on the left-hand side, you'll see examples of the kinds of things that were happening in our NMP Foundations, our developmental course. Things that they heard or kind of general observations. And then on the right-hand side, you'll see the comparisons from observations and what they heard in non-NMP type courses. And I'll just draw your attention to 3 areas in particular. The first one related to context and interdisciplinary connections. So one of the things they noted is that there was quite a bit of variation across these dimensions. And so some of the variation comes here in the context and interdisciplinary connections area, where you see on the right-hand side, kind of the traditional classroom, you're hearing things like solve for X, plug in the number, use your formulas, you know, that kind of thing. Whereas in the Foundations courses, what they saw is much more use of real-life examples and coursework framed in a way that motivated why the skills were being developed and how they would be used in context. Another area of key difference is, if you come down a little bit to the problem-solving area, is that in traditional classrooms, the way to solve a problem was typically presented as a single way to solve a problem. This is, you know, use this formula, plug it in, this is how you find the answer. But in the NMP courses, there was much more attention to multiple ways to solve a problem, so that there might be different ways to kind of reason through an issue, and you might come to your solution from a couple of different ways. And I think you'll see this, you know, this was related in many ways to the last one around active learning that you'll see at the bottom of the list, that in NMP classrooms, there's a real emphasis on active learning and helping, having students work in small groups with some lecture, but more faculty or instructor scaffolding or facilitation, but a lot more of students kind of hands-on grappling with the work, as opposed to primarily lecture with then opportunity for individual practice, as they saw, MDRC saw in the non-NMP classrooms. And then just to finish this piece, I wanted to end with a quote that I think kind of highlights some of the differences that we're seeing in this approach. Is a student said, "I don't see a math problem and go, this is completely impossible anymore. I look at the problem and actually try to solve it." So I think some of what's embedded in here is one, seeing problems that are relevant, actually sometimes are more motivating to students, and the idea that students really need to use their reasoning skills, not their memorization skills, in order to grapple with mathematics, learn mathematics, and be able to apply it flexibly. So in general, we saw the positive perceptions of the course, especially about contextualization, although there was some mixed feedback so far about active learning pedagogy. We know that sometimes students are uncomfortable working in groups, that sometimes students don't like it. Sometimes students feel more comfortable in a traditional classroom setting, and so that's some of what I think we're seeing related to mixed opinions around some of the active learning approaches in our work. So with that, I will pass it off to get a specific example from Doug about the work going on in Oregon.
Actually, before we pass it on to Doug, Jenna, we have had a few questions from the audience. Can you just speak very, very briefly about how the Math Pathways work might be trickling down to the high schools, and if any of your content's aligned with Common Core?
So I will say that the extension down to K-12 is something we are working on now, and is fairly nascent, but something that we see as being really important. So there certainly are some connections in terms of the thrust of Common Core, in terms of a heavier emphasis and acknowledgement that statistics is an important area for student learning, and so I think, you know, the idea of relevance and exposure to different kinds of math content, there's a real similarity there. Also, I would say that I'll talk specifically in the Texas context, but I think this is relevant in lots of places, is that we see kind of 3 areas for K-12 connection. And one is kind of the explosion of transition courses or college prep courses for students who are not college ready in that senior year. There's interest in what kinds of mathematics is most relevant for students there and trying to expose them to statistics, quantitative reasoning, and algebra that they may need to move into college. The other areas are dual enrollment and how students are advised when they're having that early on-ramp into college and what math would be most relevant for them. And then also in terms of the actual 3rd and 4th year courses for students who are on track to be college ready, what's kind of the best uses of those, given that we believe 4 years of math is really important for strong preparation to move into college level math.
Okay, thank you very much. Now we'll hear from Doug.
Thanks, Jenna. Greetings, everyone. My name is Doug Nelson. I'm a math instructor at Central Oregon Community College, and I kind of wanted to share with you a little bit of what Oregon has been doing along the lines of what Jenna outlined from the Dana Center, as well as what Michelle's been talking about early on. We certainly have motivation. We've all seen the problems or heard about the problems in the math faculty here in this state. We're concerned about the lack of increase or lack of students able to actually attain their academic goals. We wanted to work on getting that better. We know that we have too many exit points. We've seen it. We still have too many at my institution, and we're working on that as well. We know that students sit in math classes and have difficulty trying to figure out how that's relevant with where they're going and what they want to actually do in life. And finally, the college algebra does a great job of preparing students to move on into pre-calc and calculus, that as we've seen and we understand, a lot of those students aren't getting into the STEM fields. So Oregon then kind of came together and about 4 years ago and thought that we would try to tackle some of these concerns and see what we could do about arriving at good solutions. I'll give you a snapshot at my particular school at COCC. That's our current developmental, call it a STEM pathway. That's been the pathway that's been at COCC since I've been there. There's ongoing discussion work to start to shorten this and to kind of change a little bit of the curriculum in there. This is the current new math pathway that we have at COCC. We're calling it our alternate pathway. It's been in place now for about a year. And you can see that here not only is the path shorter, but the actual courses that students are taking are more relevant toward humanities, let's say fine arts, maybe a sociology major. Those quantitative literacy courses, I'll give you some more specifics into those courses as well as the Math 105 class down there. But they can also be used to help students that are going on in statistics courses as well. So in a way, as Jenna was alluding to, having 3 pathways, we kind of have 2, yet our alternate pathway can kind of serve both purposes of getting students into statistical courses as well as getting students that are just heading toward, let's say, fine arts or something. That developmental math course 10, which is that first entry course in our alternate pathway, we have in place ways for students to develop those skills without actually taking the full course. So again, that sequence is much shorter than what we had or what we still have in our traditional math pathways. It certainly helps people and students that are coming to our schools with their self-confidence when they end up more in the alternate pathway than back into the traditional math that they've seen before. I think they feel much better about what they're learning and seeing with that. I think we're finding it to serve well. I'll kind of get back to that toward the end of some of the specifics on that as well. So let me back up for a little bit and kind of give you an idea of what took place here in Oregon. About 4 years ago, under the leadership of the Oregon Community College Association and Elizabeth Cox Brand, she started bringing math faculty together on a regular basis. We discussed the current situation. We discussed the problems. We started coming up with solutions to the problems that we were facing, and we came up with some recommendations. And one of the recommendations that came from that larger group that was meeting several years ago was that we would bring faculty, math faculty together and have a convening to discuss the current Math 105 class. So that class has been on the books since I came to Oregon in '94. And we also wanted to have a second convening of math folks to talk about the sort of prereq course, the capstone, if you will, developmental alternate pathway class. So in the fall of 2014, we had math faculty from all 17 community colleges. We had faculty from the 7 public universities. We had representatives from our community college and workforce development, OCCA, which I mentioned earlier. Department of Ed was in attendance, and our higher educating sort of council there, the coordinating commission, were also in attendance. And what those folks did in the fall of 2014 was develop a document that outlined the outcomes that we wanted to have in that 105 class. Since we were given it a fresh look, we changed its name. It used to be called Contemporary Mathematics or Math for Liberal Arts. We changed it to Math and Society and rewrote the course description and came up with the outcomes for that course, which I'll share with you in a minute. And that document took about 5 to 6 months to complete until we were able to get a final copy that everybody signed off on. We borrowed information from the state of Washington. They had done this work about a year before we started, so we were able to tap into some of the great work they had done as well. Meanwhile, in the winter of 2015, we had another group get together, and those folks really just focused on what Math 98 would be. So what would be that prereq skill leading into our Math and Society course in this state? We had a little representation from the public universities, but for those folks, they're not developing those courses. They were more involved with the development of the Math 105 than the Math 98 courses. So let me give you a little peek into what these courses look like now. This is the Math 105, the Math and Society. It has 3 major topics in it: logical reasoning, probability statistics, and financial literacy. So sort of supporting topics that you'll find under there. If you were to look under logical reasoning, these students are working on describing and critiquing arguments, recognizing common logical fallacies, learning problem-solving strategies. When you get into the probability and statistics, they're working on counting, measure the central tendency, interpreting graphical displays, working with margin of errors. And then financial literacy is covering areas such as loans, credit cards, annuities, income tax, compound interest. The course had always had in its existence sort of a flexibility feel to it, something that allowed an instructor based off of the current student population or maybe the mission of the college. It gave them flexibility as to the types of topics they wanted to cover, so we didn't want to lose that flavor. So we built into the course this 30% sort of wiggle room, if you will, that an instructor can either drill down deeper into one of those 3 major topics, or they could branch off into some additional topics such as graph theory, modeling growth. They could be playing around with music, something that might tweak the interest of the students that they have currently at that time. I'll give you a look at what the 98 course looks like in the state, what this group came up with that met in the winter of 15. And I laid it alongside of COCC's Math 95 course. So the Math 95 course is our intermediate algebra course. It's the prereq class to get into college algebra. The Math 98 is our Quantitative Literacy course, which is the prereq course to get into Math 105. Keep in mind that Math 105 has always had a Math 95 prereq, so that still doesn't change. Students can still go from intermediate algebra into 105, but we wanted to develop a pathway to allow students a little better relevancy in maybe their careers to be able to run from 98 into the 105. So the 98 outcomes, we have number sense in there, which are things like percents and ratios, unit analysis. We have applied algebraic reasoning, so they're working with formulas, understanding slopes, rates of change, doing proportional reasoning, looking and understanding what linear and nonlinear relationships are like. We have graphical sense, so they're reading, creating, and interpreting graphs, recognizing patterns. We have measurement, so they're doing perimeter, volume, area, working with some right triangle trig. And then under statistical reasoning, you're doing things like working with means and medians, normal distributions, standard deviation, that kind of idea. The Math 95, I'll show you what we have at COCC, and this changes slightly from some other institutions in the state. We do lines and quadratic work. We work with functions, deal with the graphing calculator a lot, deal with application, and work with systems of equations. A very traditional intermediate algebra. There are a few schools in our state that actually do exponential and log functions in their Math 95 as well. That's kind of what we have at our school. So if I was going to summarize it, somebody says to me, you know, hey Doug, what is Math 98 and then what is Math 95? I guess my summary would be that Math 98 kind of is the math you want your neighbor to know, and Math 95 is really a tool builder, gets you ready for future math courses, STEM fields that you're walking into, and I think that's really sort of the defining difference between those two courses that we have. Now, when all this work was being done, which was great that we got ourselves started, we were able to actually complete this work in a school year by the great efforts of a lot of people. And one hurdle we had is that in the state of Oregon, our Associate of Arts Oregon transfer degree had language on it that said if you're going to use a math course that satisfies the AAOT degree, that math course has to be one for which intermediate algebra is a prereq. Well, obviously, that was a problem because we were trying to develop a Math 98 course, which is obviously not intermediate algebra. So what had to take place is we first had to revise the statement, which we did, and then that statement had to be filtered through all of the major groups throughout this state, including provosts, president's council, council for instructional administrators, and that work was really driven through by OCCA. Elizabeth Cox-Brand and Lisa Reynolds helped a lot from the HEC to get all those different groups to sign off so that our language for our AOT is now such that we can offer now 98 to run to 105, and 105 can still satisfy your math requirements for the AAOT degree. So the alternate pathway at COCC hasn't been in place for too long. It's only been there for this year, but we're already noticing that we're getting students better advised into which pathways to go based off of what they want to achieve as a certificate or degree or four-year degree. We're finding that our 105 students actually have a little better preparation than the students that are coming out of Math 95 in terms of critical thinking skills. And it has allowed us to start looking a little bit closer at that STEM pathway, that STEM prep pathway, if you will, to start looking at the curriculum, because we're noticing our students that are in those courses, especially the 95 class, are typically the ones that really need 111 for what they're trying to pursue. So we can look really at trying to offer them the best curriculum possible. Another byproduct that we've seen from developing the alternate pathway is the communication that's now developed with the high schools. Not only throughout the state, I can talk specifically in Central Oregon, where our school is, that we're now having better dialogue with our high school partners. We've had some teachers in our local high schools ask us about whether or not they could start offering our Math 105 course as a college now or dual credit course. This is a course that they teach to their students in their building and give them our credit. So there's been some dialogue going on. Nothing is established yet with that. That conversation is going to continue on into next year. We've also noticed that there's some dialogue going on now in the high school levels about developing alternative non-STEM courses so that students that are identifying themselves as getting into fields outside of STEM fields, what can those high schools offer? And so there's been some discussions going on at that level. And then we also have now math teachers and college faculty getting together to really work on aligning the curriculum better. I know there's going to be some work done in this state this summer regarding that last bullet. So that kind of gives you a snapshot of what we did. It was a lot of heavy lifting. We were able to do it in a short period of time, which was phenomenal, so that we could get kind of back to our students and get working on what we were going to do. And I'll kind of wrap it up with that, and I'll turn it back over to Allison.
All right, thank you, Doug. This is Michelle again. So we're going to ask Doug and Jenna some questions from the audience. So one question we received is about if any of these math pathways overlap with Perkins or CTE programs.
Jenna, I guess I'll try to tackle that one.
Okay.
You know, our quantitative literacy courses, our CTE folks, which deal with Perkins grants and funds, our career technical education folks, and the certificate students can get. We're having dialogue with our CTE folks now. We're talking to their advisory councils about what quantitative literacy really is, and they're making decisions based on state requirements or local requirements on whether or not they want to shift away from what was traditionally, let's say, a beginning algebra requirement and make the math requirement more into a quantitative literacy. So I would say yes, that probably within a year or two, we're going to see more of the CTE requirements shifting towards the alternate pathway, which of course those folks in those programs are dealing with the Perkins funds.
And I would add from the Texas context, we see kind of three different strategies. One is many programs just require students to achieve college readiness. They don't require a college-level math course. So for a lot of those programs, folks are using our Foundations course or similar to what Doug's talking about, his Math 98, kind of quantitative reasoning-based developmental course to get students done in a semester and ready to move into their certificate or program. The other thing, if people do need a college-level math course, sometimes they're using the college-level quantitative reasoning course, and in other times they're using what they call a tech math, college-level tech math, which has a little bit more, some of the algebraic reasoning skills in it, because sometimes there are particular skills that students need if they're going to be in, you know, a chemistry or maybe need a particular science class as part of their workforce program.
Okay, thank you. And Jenna, we have a question. Is there interest in from Alaska in working with the Dana Center?
You know, Alaska is one of all the ones in the group. Alaska is one that I don't know of, or I haven't heard anything from in terms of whether they're already starting this work. I know Idaho is taking on some of this work independently, and as we said, Washington and Montana, but I haven't heard anything about Alaska, but we're always open to talking to new states, so.
Okay, thank you. And then for you, Doug, we had another question about student experiences in the math courses at COCC, and in particular, if you can speak to any class size issues as you've introduced a new math pathway.
Yeah, that's a great question, Michelle. What we did with our quantitative literacy courses is we dropped the cap size of those classes. Those students are doing a lot of group work, a lot of idea exchange, and that we didn't want to have big groups, so we dropped our class size down to 30 in that, where our other classes are capped more at 35. And we've noticed now that we've picked up more sections of those courses. Again, that directly comes back from the advising piece as well. But it is something you have to be sensitive to, because the curriculum and sort of the organization of the course is a little bit different than what you would typically be doing in your traditional developmental courses.
Okay, thank you. And another question is, what do you, Doug, what advice do you have for faculty or other listeners about if they want to do something similar that Oregon did? What's the most important thing they should know?
Wow, the most important thing, just one? Well, first of all, and Jenna hit this right on the head early on in her presentation, you've got to have leadership from above, and so you need to have some sort of state organization, and for us it was the Oregon Community College Association. You have to have some organization that's going to be able to provide the resources to be able to bring people together. So you've got to get people together face to face and meet and discuss and talk about what it is that they would like to do. I think the other thing that needs to branch from that is that you need to have consistency throughout the state. You don't want to have students have transferability issues. So you don't want a student to have to go from one school to another school and find out that that school is not taking something because the prereqs weren't met or they don't like that course that's offered. So you need to make sure you have that consistency. But you certainly have to have the faculty doing the heavy lifting, but you have to have some sort of higher organization sort of doing the guiding and providing the resources. And the leadership, especially at the legislative level, I have a working sort of arrangement with OCCA and Elizabeth Cox-Brand that when it comes politically, she takes the ball, and when it comes dealing with faculty, I take the ball. So you need to have those sort of pieces and people in place.
And if I could just weigh in on that, I would thoroughly underline everything that Doug just said. I think that's exactly right on. And just two additions, you know, at the state level, I would say just know that there's a lot of work in terms of identifying learning outcomes, in terms of the process of doing this work. Many states have taken this on already, so there's no need to start from scratch. You know, I frankly just borrowed something from the Oregon model that I repurposed in Texas. So, you know, there's a lot of work to build on here, and so, you know, take those tools and resources, and there's a lot of interest in sharing and helping other states move forward. And then the other is, sometimes states aren't quite ready to move as a full state. So if you are a single faculty member and you're interested in this and your institution has never tried it, there aren't others in your state that are really doing a lot, you know, I think it takes some proof points within the state to typically start building momentum. So you might start working at your own institution, start implementing some sections, you know, use what flexibility you have in your current policy structure. But I do think it helps to start with some proof points in your state and then build momentum from there in terms of neighboring colleges, neighboring universities, and really start, you know, to push. And I think, especially if this is a community college audience, I would encourage you to look at the work of your 4 years. Many 4 years have kind of already moved in this multiple math pathways direction, but they're not thinking about it from a developmental ed context. So really take a look at what universities are doing, and many are already using kind of a quantitative reasoning type course or a statistics type course. So there might be assets for you to build on even in your own region or state.
Okay, thank you so much. If there's any, are there any last words that either of you have?
Well, I guess this is Doug. I would just say with a little bit of what Jenna had just mentioned, I wouldn't be hesitant as an individual school of moving forward, even if you felt that the state around you wasn't doing much at this point. I think that you can start moving people in that direction by working internally. Sometimes easier to work with your own and then move further out. And certainly tap into what the four-year schools are doing. As a community college, we've got people on either end of us. So look at the four-year schools and then keep talking and working with your local high schools. What are you guys doing about curriculum? Would this be advantageous to you if we developed something like that? I just had a conversation with a colleague from a high school, a rural high school in Eastern Oregon, and he said to me, wow, you know what, if we've got that in place at the college now where they can take a 105 class, then maybe we really should be looking at doing something with our curriculum to allow students to better feed into that as opposed to always preparing them just for that college algebra course.
And
great.
I would say, could I offer a couple of final thoughts very quickly? Three quick thoughts. One is, I think this is an idea that makes a lot of intuitive sense to people. As you start talking about this, you know, having a good answer for students when they say, why do I have to learn this, is really satisfying. That, you know, instructors, K-12, higher ed, you know, it's really something that most people want to be able to answer that and be able to make those connections for students. In general, eliminating or reducing the number of exit points is kind of a primary thrust of this piece, of this approach. And then finally, you know, one of the common things you'll hear is whether this is a reduction of rigor in some way, and I would just encourage you to turn to your math professional societies and say, no, this isn't about watering the student experience down or mathematics down. This is really about the relevance, and there is broad support for that. So those are some of the final tools and thoughts that I would encourage you to leverage.
Thank you so much. And thank you all for participating. We in the U.S. Department of Education value your feedback, so please take our survey when it comes up on your screen. It only takes less than 5 minutes. Thank you all. Thank you to the panelists and the participants.
Thanks, everybody. Bye-bye.